And this warm-up will help us with what we're doing today. So our f of x in this case is x squared plus 3. So I'm just going to plug negative 1 in. And I end up with positive 1 plus 3, which is 4. So negative 1 comma 4 would be one of my ordered pairs. And then I plug in 0, and it's the same idea. I would do 0 squared plus 3, which is just 3. So 0, 3 would be my ordered pair. And then I plug in 1, which gives me 4. And so I get 1, 4. And so here's what my, let me try to connect those a little better. Here's what my graph looks like. And if you think about the graph that we had yesterday for x squared, so I'll do this in red. So this is what our x squared looked like yesterday. So you can see if we have x squared plus 3, it's basically the same graph, but the difference is it just took the graph and it moved it up 3. That's called a vertical translation, and we're learning about transformations of functions today. So this is a really great lesson because it will teach you things about functions that will work for any future functions in any of your math classes. So like if you have trigonometry, you could still use what you're learning today. Those ideas will help you with your future functions that you'll have. And of course, it's helpful in this class because it's part of our curriculum is to be able to describe transformations and graph transformations. Okay, and remember, some of you have not started your homework on MyLabs. Everything is due on Monday for this week, and there's a list that I'll show you at the end if you missed it at the beginning. And it's soft due dates, but I would not get behind, because if you get behind, it's really hard to keep up in a class that goes this fast. We are going to test review on Monday, and then your test will be open for you to take. Okay, we're going to start with vertical translations, except for we're not going to have to make exhaustive tables anymore. We're going to use what we just did on our warm-up to actually help us. So if you think about the absolute value of x, which is a V shape, if I have the absolute value of x plus 4, then that's just going to take my graph and it's going to move it up 4. So part of our objective is what we call describing the transformation. So to describe this transformation, I would say that it is a vertical translation up 4. And if you think about the word vertical in general, if any of you are athletes, you may have tested your vertical at some point where they basically see how high you can jump. I remember that they did this to me when I was playing basketball in high school. They were testing my vertical, and so I would run and then I would just jump as high as I could jump, and that would be considered my vertical, that length. And then of course horizontal would be left and right. So vertical is up and down. If it's a positive 4, it's going to move our graph up 4. If it's a negative, it's going to move it down. So this would be a vertical translation down 2. And other words that you can see that they'll use is called a shift. So you can see translation or shift, and that just means the same thing. So if you can imagine our graph, if I'm going to create a new graph of this absolute value of x plus 4, all I have to do is take my original graph and just move a few of those ordered pairs up 4. So this whole graph, I would just redraw, literally moving it up 4. Now, you could also create a table if you wanted to. You could create a table of values, and what would happen is your ordered pairs would be such that they would have all moved up 4. So the table is always a good thing that you could fall back on if you ever were not sure what the transformations were. But by the time we finish this lesson, you're probably going to have them memorized naturally. And then to graph the absolute value of x minus 2, I would just shift my ordered pairs down 2. So this absolute value of x, we call it our parent function. And when we have transformations, we can apply our transformations to our parent function. So if I'm going to do the absolute value of x minus 2, I just take those ordered pairs that are on my parent function, and I would just move each of them down 2 to get my new ordered pairs. And that's really not too difficult to do. And we're graphing these by hand, but on MyLabs, they actually use the graphing feature to do it. And so I did make a video to show you how they're going to have you type that in, because you'll actually be using the transformations to graph it on MyLabs. Are there any questions on this first idea, first concept? Okay, just give me a thumbs up when you're good for me to move on, because I don't want to go too fast, and I'm not sure how many of you are able to print the notes, because I know printing the notes definitely helps. Okay, I think we had enough thumbs up, so I'm going to keep moving along here. Let's try the horizontal translations. Okay, now these are crazy, and what I like to do is I like to write the word horizontal with a parentheses, because when you have parentheses, that means the graph is going to move left or right. So horizontal itself is talking about left and right. You'll know it's a horizontal translation when you see parentheses. And it's really obvious with quadratics, which are naturally in parentheses, but sometimes we have to be careful, because like if I had the square root of x plus 2 and then like minus 3, there are invisible parentheses inside of the square root, but we don't draw them anymore. So this would be a horizontal translation there. So if it's in parentheses, it's either going to move the graph left or right, but it's not as intuitive as you would imagine. In fact, it's a little crazy. But if it's a positive 2, it's actually going to move our graph to the left and not to the right. So this would be a horizontal translation to the left 2. That's very difficult for students to understand, but I promise you, and if you have more time this evening and you just want to do this for fun, you could actually create your own table of values and plug them in and then graph it, and you would see that naturally the graph does shift to the left 2 instead of to the right. So when it's in parentheses, it's going to move it left or right. If it's positive, it's going to make it go to the left, and if it's negative, it's actually going to make it go to the right. So this one here, we would describe as a horizontal translation or shift to the right 1. And we can graph this pretty quickly. Oh, great. Okay, we're good. Sorry, I just got a message that my internet is like messing up. I think you guys can hear me, right? I'm not like frozen. Okay. All right. So I'm going to move this to the left 2. So I'm going to take my ordered pairs, and I would just move all of these to the left 2. I'll do this in red. And you don't have to go like over the top crazy. You can just do a few of the ordered pairs to show that the graph just moves to the left 2. So the graph that's graphed, of course, is our parent function. That's x squared. And then if I have the x plus 2 squared, that's going to move that graph to the left 2. So I just take that parent function and I just shift it to the left 2. And then for my horizontal translation to the right 1, I would do a similar thing. I would just move these ordered pairs to the right 1. And now these are kind of on top of each other. So it's kind of difficult to see. So I try to do it in different colors to help you. But that's what that would look like. So you can imagine if I had like x minus 5 squared, then that would move it to the right 5. And if I put a plus 12 on this, it would also move it up 12. So the transformations are not that bad, like separate, but when we put them all, when we mix them all together, that's when it can get a little bit confusing. So the cool thing about transformations is like you'll be able to sketch graphs faster than your calculator. Like we had these really nice calculators at the school that I was at, and students were able to actually graph by hand faster than typing it into their calculator. And remember, if you get kicked out, I will let you back in. It's happened to a few people this evening. And I am drinking out of my Harry Potter cup today, just in case, you're a Harry Potter fan. If you haven't read the books, you should. Okay, thumbs up. Can I keep going? You guys are good? We're good? Okay, cool. All right, so let's move into another transformation, which is called reflections. Is it okay for me to go? And I am recording this, so if you miss something, like if you get kicked out, you can definitely watch the video or stay on and I can go back and explain it to you. Okay, so we're going to now talk about reflections. Reflections are kind of cool. We have a few things that can happen to our parent function. So this time our parent function is the square root of x, which we graphed yesterday. So there's the square root of x. And then if I put a negative in front of the square root of x, it does something special to my graph. It reflects the x-axis. And so if you created a table of values, which at this point I have to be honest, the table of values becomes exhaustive, right? It takes a long time. If you can imagine, if we were going to create a table of values for each of these, it would take a really long time. So if you did, though, you would see that it reflects the x-axis, or even if you wanted to use a calculator and see what that table looks like. So what that means is it takes these ordered pairs. So the 0, 0 kind of stays the same, right? But this ordered pair here, if I reflect the x-axis, and I'll do this in green, it's actually going to make it go down below the x-axis. And then my other ordered pairs would do the same thing. So like this one in blue would kind of be in the same location, but instead of being at 4, 2, it would actually be at 4, negative 2, and so on. And so what happens is it ends up looking like this. So this is negative square root of x. So essentially it takes the y values and it makes them negative. Now, if this middle one reflects the x-axis, what do you think the negative does inside of the function? Any ideas? Did somebody type it in? Reflects across the y-axis. Yes, that is correct. Good job, Cyril. You were really fast at typing, by the way. That was impressive. You must be like a fast typer. Okay, so yes, this one actually reflects the y-axis. And just a reminder that this is my x-axis. So if you think about what that graph did, is it just flips over the x-axis. That means it reflects. And then my y-axis I'll highlight in blue for you. So here's the y-axis. That graph will go the other way. It's kind of hard to do with my arm, but it'll look like that. And I'll do this in red. So I'll still have my ordered pair at 0, 0, but instead I'll have an ordered pair at negative 1, positive 1, and then I'll have an ordered pair at negative 4, positive 2, and then I would also have an ordered pair at negative 9, 3, and so it would look like this. So that ordered pair 4, 2 would be transformed as negative 4, 2. So when this happens, the x values become negative to our parent function, while up here, the y values become negative. Okay, but like I said, I would say your main objective is being able to describe the transformations. Okay, so let's do a little recap, because I know and I hope some of you guys were writing that, so I'll go. Okay, so I want to challenge you just with what we have so far. Okay, so I'm going to ask you to type into the chat. So describe the transformations of, and I'm going to make this advanced because I'm going to mix these together. Okay, that's what makes this more difficult. So I'm going to put a negative here, and then I'm going to do this. Okay, there are 3 transformations. Try to type in what you think they are. So I'll give you a moment to try to type that in. You guys are doing pretty good, right? I had some people that just typed it directly into the chat, which is totally fine. And then I had some people send me a private message. Okay, but I feel bad because sometimes I don't see all of your messages and I'm on 2 screens. So if I don't ever respond to you, I promise it's not on purpose. It's just like craziness going on. Okay, so let's see how you guys did. I have a negative. That's going to make it reflect the x-axis since it's in front of the function. And then the x plus 5 will be a horizontal shift to the left, or translation, you can use either word. So that would be to the left 5. I know it's crazy, but because it's a positive, it actually moves it to the left and not the right. And then the minus 7 is a vertical shift. Ooh, let me spell that right, sorry. A vertical shift down 7. And that you just take it for what it's worth. If it's positive, it's going to move it up. If it's negative, it's going to move it down. Okay, great job. You guys are doing awesome because it's not over. We have more transformations. And usually I teach this in like a 2-day thing, but we're doing this all tonight, but that's how it works. Okay, is it okay for me to click? You guys good? Good. Okay, awesome. All right, so let's go to the next slide. Now we're going to talk about vertical stretching and shrinking. Now, I want to include the word compression here. That is the same thing as shrinking. So you'll see either word, and so I just want to add that in there. It kind of bothers me that they didn't already type that in. Okay, so vertical stretch and compression or shrinking is when we actually take the graph itself, and we don't necessarily shift it, but we take the ends of it and we do things to it, right? So if you think about a vertical stretch, what that would do to my graph. If you can imagine that this is my graph and I'm going to vertically stretch it. So I'm going to take the ends of my graph, I'm going to take the ends and I'm going to stretch them. Well, when I do this, it actually makes my graph more narrow. So it kind of narrows my graph. While a vertical shrink or compression would compress vertically, would go like this, and for it to try to fit into that space, it would get wider and wider and wider. So that's what's happening with our graphs. Now I'm doing probably a terrible job trying to show you guys with my hands, but I'm going to show you with the graph, and it'll hopefully be a little better. Okay, so if the number, so it's all about the multiplication of the parent function. That's what causes a vertical stretch or shrink. So when I see this 2x squared, it's really 2 times x squared, and that's what causes my vertical stretch. So this would be a vertical stretch by a factor of 2. And so what that's going to do is that's going to take my ordered pair that looks like that, and the 0, 0 is not going to be affected, right? But my next ordered pair on my parent function, which is 1, 1, what's going to happen is it's going to make the y value multiplied by 2. So my y value will be multiplied by 2. So that means that new ordered pair would be 1, 2. And then the same thing would happen over here. So that ordered pair is -1, 1. I would do the same thing. Basically all of my y values, I'll be multiplying them by 2. And so you can see like what kind of effect this is going to have on my graph, right? You can already tell by these few ordered pairs that what ends up happening is it becomes more narrow. And we call that a vertical stretch. And what's cool about this is the larger the number, the more stretched the graph becomes. For example, I'll do this in yellow. If I was going to graph 5x squared, it would be even more narrow. And if I tried to do like 100x squared, it would be like so narrow. It would be very difficult for us to even see it on our graph. We'd have to like zoom to a certain zoom to see it. So the higher the number, the more it's going to be stretched. If the number is in between 0 and 1, such as 1/2, then that creates what we call a vertical shrink by a factor of 1/2. Which means instead of multiplying our y values by 2, I'm going to multiply the y values by 1/2. And when I multiply them by 1/2, of course, they're going to get smaller. And that's what causes that shrink. So for example, we have the two ordered pairs, right? We have 1, 1, we have negative 1, 1. And these are from our parent function, our basic parent function of x squared. When we transform these, our y coordinates, we multiply by 1/2. And so my new ordered pair would be 1, 1/2 and negative 1, 1/2. And that's just going to take the graph and it's going to make it wider. So I'm going to try my best to graph this, but it's kind of sad because, I'm going to do this in green. Like I need more room or something. But that's what it would look like. It would be wider. That would be 1/2 x squared. And also, the lower the number of the fraction or decimal, like if it was 1/10, it would be even wider. And if it was 1/100, it would be like ridiculously wide. It'd be really hard for us to see, but it would be a wider graph. Like I said, what's really cool about these transformations is they work for all parent functions, including trigonomic functions in future math classes. All right, so the same thing is going to happen on the graph below with our absolute value. If I have a 2 in front of it, it's going to be described as a vertical stretch by 2. And the 1/2 would be a vertical shrink by 1/2. And I will draw these for you on my graph. Now you can choose a few ordered pairs and you can actually transform them by multiplying the y value by 2 like we did before, and that would totally work. In fact, the ordered pair 1, 1 we can still use, and actually negative 1, 1 we can use as well. We would just multiply these by 2. So I would have an ordered pair at 1, 2, negative 1, 2, and so on. We could do that for all of these ordered pairs. And what ends up happening is we get this graph that is narrow. It's more narrow. So this would be 2 absolute value of x. And then the vertical shrink by 1/2, similar thing would happen. I would multiply the values by 1/2. And so it would be a wider graph. It would look like that. Are there any questions on these transformations? You guys are doing pretty good. This is, like I said, I know it's a lot of information. And in this class, it'll continue this way with a lot of information, but it's okay. It's fast and furious, and you guys are doing great so far. So you just got to keep up the hard work. Okay, we're going to now be, sorry. We have some people having issues. They keep getting kicked out. Okay, so we're now going to talk about the summary part of this. Okay, so if you were able to print the notes, that's awesome. If not, it's okay too. this is what it looks like. And let me see. I want to make sure that I posted this. Let me see. I did post these notes, right? I did. Okay, good. Jeez. It's like so many little things that I don't want to forget to do. Okay, I need to let this person back in. Okay, we're good. All right. So this is a summary of all the transformations, and we have the graph of y equals f of x plus k. That will translate the graph k units up. So this is like if you Googled transformations of functions, like this is like what you would see. This is just like the summary of everything. And then if it's a minus k, it's going to take the k units down. And then if we have the parentheses, that's the horizontal transformation or translation. And so remember, if it's a positive h, it's going to move it h units, but to the left. And if it's a negative h, it's going to move it h units to the right. And then we have a vertical stretch. So if we have a factor of a, we will say it's a vertical stretch when a is greater than 1. And we call it a vertical shrink or compression when a is in between 0 and 1. So this just means a is in between 0 and 1. Whoops, hold on, sorry. Okay, let me move this all up together. Nope, let me move it all up together. Why isn't it letting me? Oh no, I'm afraid to touch it now. Okay, it's okay. Now, if the graph of y equals negative f of x, so if the negative's in front, it's going to reflect, Okay, it's going to reflect across, I don't like the way that looks. Let me fix that. Okay, sorry. It's going to reflect across the x-axis. And then and here we go, I'm going to try to, now it's letting me do it, geez. Okay, if the graph of y equals f and the negative is inside the parentheses, if it's inside the parentheses right in front of the x, that's the difference, then it's going to be a reflection across the y-axis. All right. Are there any questions on that part of the summary? Because we've got like some more, and then we'll do more examples. You guys are good? Okay, so just give me a thumbs up when you're ready for me to move. Okay. I think I see a bunch, and then I see some people not doing anything. So, okay, so let's go ahead and move on to some more. Now, I'm not really going to go through this for very long, because this is really just like everything we just said. So if we have an a in front, of course, it's a vertical stretch or a shrink, but it does kind of help you in a way, because it does tell you the y coordinates of the graph can be obtained by multiplying the y coordinate by a. And so that's kind of like a good thing, a good trick that might help you that we kind of already did. And then for our reflections, if we have a negative in front of f of x, then it will be the opposite of the y coordinates, which we also talked about. And if the negative is inside where the x is, then what that does is it actually changes your x coordinates. And so that might be something that will help you as well. However, I do feel like, especially in my labs, you're using that graphing feature and you're describing the transformations. There's no way for us to test you on graphing this by hand, if that makes sense. So like we do it by hand to show you visually like what's going on, But you really just need to know those transformations, be able to describe the transformations, and maybe to match the graph. All right, so we're going to do a few examples together, and we'll go ahead and get started on those. And this is where we kind of like mix them together. Okay, is it okay if I go? You guys are good? Okay, cool. All right, so we're going to be graphing the function. On MyLabs, it will make you like type in the transformations, which is why I'm going to have you, part of your lesson tonight is to watch that less than 5-minute video just to show you how MyLabs expects you to do it, because I know that it will upset people if they don't know how to do that. Okay, so let's describe the transformations first. The negative in front would do what to my graph? You can either unmute and tell us, or you can type it in. X-axis reflection. Yes, thank you, Caitlin. It reflects the x-axis. Yes. Okay, now somebody different has to help us with the x plus 3. What is that going to do? You can either unmute or type it in. Yes, thank you, Alina. Left 3. All right, and then somebody different, what about the plus 1? I'll do this in green. Up 1, thank you, Cyril. Okay, perfect. So we're gonna get to do all of these transformations. And look, you don't have to go too crazy with your graph. You just want to show that we definitely moved it to the left 3, and we moved it up 1, and we also reflected it. Okay, so I like to focus on that main ordered pair, which is the origin. It's just easier to show that. So I'm going to go to the left 3, and then I'm going to go up 1, and then I'm going to make sure to reflect my graph across the x-axis. So it would look like this. And like I said, it doesn't have to be perfect. You can do as many ordered pairs as you want, or you could just do that like vertex part, the origin part. You don't have to do all the ordered pairs. As long as you understand what that graph, that general shape looks like, and where it's located on our coordinate plane. Which there is a tie-in, of course, to our vertex form from a few days ago, because if we have a negative, it makes sense that that x-coordinate would be a positive now that we know our transformations. Okay, so the 2 will be a vertical stretch or shrink. What do you think? Vertical stretch or vertical shrink? Stretch, thank you. Okay, it is going to be a vertical stretch. And then the -4 will just take us to the right 4. All right, so I'm going to go ahead and go to the right 4. And then I would do a vertical stretch by 2, right? So I want to make that by 2. So I would go here and there. And you can always write those ordered pairs down if you need to, but I know that this is at 1 and this is at 1, so all I had to do was go up to 2. But on your MyLabs, well, you'll see, like I said, there's a certain way they have you do it that's a little not as intuitive as I would hope, but I can't change it. So. Okay, we're going to do a few more with our parent functions, and then we're going to go into the weird looking graphs that are like just the function notation in general. Is it okay for me to go? You guys are good? Okay, so let's try g of x is equal to -1/2 square root of x plus 4. Okay, So we got a few transformations going on here. We have, that's 1. The 1/2 is 1. And the +4 is 1. So when you think about this, the negative is its own special transformation. We know the negative is actually going to make it reflect the x-axis. And then we know the 1/2 is a vertical shrink by 1/2. And we know that the 4 is a vertical shift up 4. So kind of a lot of things going on here. So I want to go ahead and take my main ordered pair. I'm going to move it up 4. I also want to reflect the x-axis. So that shape, this curve here, when I reflect the x-axis, it's just going to make it flip like that. So I would want to show that. And then the vertical shrink is really difficult to do because if you think about that ordered pair at 1, 1, my new ordered pair would be at like 1 and like 3.5. And so I would do my best to plot this, but it doesn't have to be necessarily perfect because it's kind of like really difficult to show this, but it would look like that. So just be like it wouldn't be as like high. It would be shrunk. Okay. So that's what that one would look like. And like I said, I know we're doing a lot of these by hand, but you mainly need to know to describe the transformations, which brings me to a special one that I'm going to add. So I want you to send me a private message this time. I want to see who all is there paying attention. Okay. And I also want to know your thoughts of this. So I want you to try this one because a lot of times people have trouble with this because there are no parentheses. So type into the chat what you think that this one would be. So there are invisible parentheses. They are right here. And if you think about our other functions, like, of course, the absolute value, the parentheses would be right there. Those are also not going to be there for you. And so we just want to kind of consider the fact that sometimes we are going to have parentheses that are invisible. So yes, if you said to the left 4, which I see one of you just typed in with a question mark, that is correct. And then down 6 is also correct. So to the left 4 and down 6. Remember, there's invisible parentheses inside of the square root. Are there any questions on that one? Okay, is it okay for me to move on? You guys are good? Okay, cool. All right, so now we have the parent function is a little different looking. It looks like that, right? But what we want you guys to realize is that it doesn't matter what the parent function is, that the transformation would still exist. This time, though, it's in function notation with f of x. And this is it's not too bad, though, but we didn't want you guys to be alarmed if you see problems like this in the future. So if I have f of x plus 3, that's just going to move it up 3. So a vertical translation up 3. And all I would need to do is take each of my, I would say like my main ordered pairs here, and I just need to shift them up 3. So it doesn't have to be perfect. You don't have to do that many. I would maybe do like, kind of like the main ones probably. Like I would just do those. Okay, so I'm going to go up 3. Up 3. Up 3. Up 3 and up 3. And then I would just kind of sketch what that would look like. So not too bad, especially if you really understand the transformation parts. Okay, we're going to try a few more of those. Is it okay for me to go? Are you guys good? Okay, so let's try this one where we're going to go to the left 3. So remember, if it's in parentheses and it's a positive, it will move it to the left. If it's a negative, it's going to move it to the right. It's kind of like counterintuitive. So I would do the same thing. I'm going to take my few ordered pairs and I'm going to move them to the left 3. And this one is kind of difficult to do. Like that one's kind of hard, but I just did my best to get it to the left 3. And then, let's see, I already did that one. This one, 1, 2, 3. This one, 1, 2, 3. There we go. Woo. All right, and then we go really crazy with this next one. So this next one, we have to move it to the right and up. So this is going to be to the right 2 and up 3. And of course, these are both vertical translations. Oh no, I'm sorry. This one is vertical. This one is horizontal. Okay, so I'm going to move it to the right 2 and I want to move it up 3. So same idea, I'm going to take this ordered pair. I'll go to the right 2 and up 3. And then I'll take this ordered pair. I'm going to go to the right 2 the best I can and then up 3. So far I would have like that. Then I go to this ordered pair. I want to go up 3 to the right 2. And then this ordered pair, up 3, 1, 2, 3. And then to the right 2. And then this last ordered pair, I would go up 3 to the right 2. Ooh, that was kind of intense. Okay, there we go. Questions for that one? Okay, so that actually covers all the content for week 1. I know we pushed really hard on Tuesday, and I knew that would make it nice for Wednesday and Thursday. I am going to show you the exit, and I want to explain to you to please watch the Graphing Functions 2 video in the Canvas homework help. It is less than 5 minutes. I would like to just do that right now. It will help you on your homework for this section because it's a specific way that MyLabs wants you to do it. Then remember, this is what's due on Monday. These are a lot of assignments. So like if we were in a regular classroom, I would give you a little bit of time to work on this and I would maybe walk around and help you with it, but we're in this remote situation. So please stay on if you need help. Otherwise, I will see you on Monday. Have a great night. Test 1 will open on Monday after our test review, and then we'll be moving into other content after that. So like I said, please stay on if you need help. Otherwise,